All right, some more basic circuit stuff. So we're going to, again, we're given a circuit. We're going to determine the voltage drops and the currents through each resistor that you see in the circuit below and solve it and see what you think, okay? So start working on that, and I'll be back in like 5 seconds to start telling the answer. So if you don't want to hear it, hit pause. Or, I mean, if you're cheating, then I don't know what you're wasting your time with. But anyways, so we'll go through this, and we'll see how you do. On your mark, set, go. Up, time's up. So this is the first step you should take in. If you did not take this as the first step, well, technically with this, I can understand if you took a different step, but you always kind of want to get this just so you can and make sure everything's working out. Although for this one, you technically don't have to do it, but I did it anyways. It's just good force to have it. So you want to find the equivalent resistance, and since they are all in parallel, we could replace all three of these resistors with a single 0.5 ohm resistor, because that's the resistance that the battery is feeling. So 0.5 ohms. All right. So that will allow me to solve for the current coming out of there. So that's what I do here. So I use V equals IR. I know the voltage drop at the source is 10. The equivalent resistance is 0.5. Solve for the total current coming out of the source, and that ends up being 20. So I'll just list that. Here's 20 amps. All right, so you have all the pieces of the puzzle. Now, since this is in parallel, you do know that the voltage drops everywhere are 10 volts. So they're all 10 volts. So this is why you don't necessarily need to do the equivalent resistance unless you're specifically asked to, because you just know that. And if you look, wow, that's 2 out of the 3 variables in Ohm's law, so I can just start solving for the current that's going to flow through there. So let's do that. All right, so there you go. These are all the voltage drops. I'm sorry, all the voltage drops are 10, so here's me solving for all of the currents through each of the resistors. So when you do this, you get the 1.5 has 6.6 amps, the 3 has 3.3 amps, and the 10 has 1 amp. So those are all the voltage drops. Now again, you're like, hey, I got them all. Those are all the currents, not the voltage drops. What am I talking about? So when you do this, then you're just like, okay, so here we've got 1 amp, 3.3 amps, and then 6.6 amps. So you basically are done, but as I always say, take a moment, double check your work before you go on. So here's my double check. All right, so here's my double check. The last thing I solved for was current. So if the last thing I solved for was current, then that means that I have to double check my current rule. And we know that the current coming out of the battery is equal to all the currents that are going to be passing through the different branches. So we've got 3 different branches that the current's going to go through. So if I add up these 3 currents, they are going to equal 20 amps, or at least that's the theory. So if you look, the source is 20, this adds up to 20, 20 equals 20. I am right, all is well. I am 100% certain I got this all right because I took the time to double check myself. All right, so if you have any questions, come in, seek some guidance. Hopefully it went well, and I will talk to you in the next one.